Hello, my name is Kenise Madhi. I am leading the newly formed technology focus area of distributed edge cloud in the office of the CTO. With me, I have my lead architect, Sven Vandermeer, and my lead scientist, Miriam Simsek. Together, we are chalking out the path to 6G for VMware. You must be thinking 5G is very early in its deployment cycle, so what's the hype about 6G? So some of it is generation, one generation going out to the market, the other entering the lab. However, the level of, passion and interest that we've seen in 6G from the government and the public sector has never been seen before, and there is a very good reason for that. The reason being that 5G was really a game changer. With 5G, the next generation evolution of wireless is not merely an evolution of performance and bandwidth. It is the evolution of the underpinning fabric of our lives. And for that, a life cycle approach has to be taken with all the sectors that contribute to our lives, being very, very interested in contributing to 6G. And VMware, of course, being front and center in almost all of these sectors, namely wireless, networking, policy, governments, cloud, of course, we are leading the charge on driving a lifecycle approach to research, marketing, and industry roadmap for 6G. We're working with many initiatives, and one of those is ATIS NextG Alliance. And with this, I would like to introduce Susan Miller of ATIS NGA to share her thoughts on how ATIS is driving a lifecycle approach to defining the national roadmap for 6G.
A little over a year ago, ATIS began discussing the critical need for North American leadership to develop a robust 6G market by the end of this decade. North America has long been a leader in driving innovative solutions to market and creating a level playing field where industry can compete and deliver powerful solutions. 6G represents the opportunity to extend wireless solutions into almost every facet of human and machine interaction. To ensure the realization of this ambitious opportunity, ATIS delivered the 6G call to action, a blueprint for industry, government, and academia to collaborate on a strategy to not only move, but to accelerate toward the realization of North American 6G and beyond. That call to action led to the formation of the NextG Alliance in late 2020, and a commitment to build the foundation for North American leadership in 6G and beyond, what we call the NextG. With strong support from a diverse base of industry leadership and government, ATIS launched the NextG Alliance. Although launched as a private sector initiative, one of the key objectives is to influence North American government and research communities to fund and architect policies in support of 6G. While it is indeed true that every company, institution, and research community will develop its own business strategy and unique product portfolio, the power of a collective vision is a NextG Alliance core principle. And this vision is not simply a set of recommendations captured in a document. The NextG Alliance is intended to drive actions across the ecosystem. The roadmap targeted for early 2022 reaches beyond R&D to look at how to incentivize manufacturing, establish standardization goals, enable market readiness, and achieve 6G market realization. We call this the life cycle view, creating an actionable strategy. Central to this is establishing 6G and beyond as a national agenda priority. VMware is front and center in the NextG Alliance with key leadership positions, setting the overall direction and strategy of the initiative, as well as working groups on societal and economic needs, and the Green G Working Group focused on sustainability. Kanice, I would personally like to thank you. I'd like to recognize and thank VMware for their leadership, as well as innovative and forward-looking technical contributions that are indeed shaping the future of 6G in North America. Thank you for having me today.
Thank you, Susan Miller, for the great overview and introduction of the ATIS NextG Alliance. VMware is happy to be one of the founding members of this alliance, and as well as being one of the co-chairs in the steering group committee of the NextG Alliance. Besides the co-leadership in the steering group, we are also actively participating in various other working groups and holding several leadership positions, such as the Green G Working Group, as well as the Societal and Economic Impacts Working Group with several of our colleagues, and are also actively participating in other working groups, such as the Roadmap Working Group in defining and driving the 6G vision and roadmap, as well as in the Technology Working Group in identifying key technologies and research problems within the path of 6G with all the other members. And I really like the approach that Susan Miller mentions, which is the power of the collective vision, which the NGA, the NextG Alliance, is following and we are contributing to. And what makes 6G different from the previous generations is actually that it's not only about the wireless or radio, but also about topics such as the digital world experience or the distributed cloud and communication systems. And this is very well reflected in the activities within the NextG Alliance. Susan also mentions that it is a collective approach with governments, industry, and academia, and that this will be reflected in various public-private partnerships. And we as VMware are already active in several public-private partnerships, such as the recently launched NSF RINGS Resilient Intelligent Next Generation Systems program, which will be introduced by Tiaga in the next video.
I am really thrilled to be here today at VMworld talking to you all about the NSF's path to 6G. We have been investing in 6G for a few years now. And even though the chatter has just picked up in the media, popular media, about what 6G is, we have been looking ahead and planning for this day a while ago. And one of the key advances we have made recently is the announcement of the RINGS program, the Resilient and Intelligent NextG Network Systems program, which is a partnership with the Department of Defense, National Institute of Science and Technology, and 9 other leading technology companies in this country, of which VMware is a key partner. VMware has partnered with us twice on similar programs before, and we are thrilled to have VMware join this big group of companies and demonstrate that a key aspect that we are all looking forward to in our NextG systems is this notion of resilience. Why resilience? We have come to depend on these networks more than ever today to be there for us at any time, at all times, to do what we want these networks to do, which is to help us communicate. We want them to be as available and as dependable. When we step out of the house, we expect the roads to be there and our cars to be able to drive on them. We want these networks to be able to provide that level of reliability and be able to count on it to do what it needs to do. And this is going to become more than important in not just 5G, but 6G networks as we start using these networks for life critical or economically critical sectors. And I want to emphasize that in the RINGS program, we are pushing resiliency along 3 different axes: adaptability, autonomy, and security. And as you can see, addressing these 3 allows a network to encounter situations that are unforeseen, could be accidental or human induced, it could be natural, but the network should be able to adapt and function regardless of the disturbances that come in. That is the goal of the RINGS program. And while we push the technological boundaries further, we want to also build resilience into these networks. And we are hoping that these advances will materialize much faster without us having to wait for 6G. Perhaps they'll even come to us even sooner than that in the 5G era itself. And that's one of the goals that we are hoping to achieve by having a robust partnership with companies who can translate them to practice faster. And we are hoping that VMware will continue this partnership with us. They have had 2 successful partnerships with us before Rings, and we are hoping that they will continue partnering with us going forward on topics like this and other areas of interest. Thank you.
Thank you very much, Tiago, for this summary of NSF activities. And I think it's fascinating to see that there is a huge support for science and research in these areas for cloud connectivity, the crossover between enterprise and other technologies. If you listen to Tiago carefully, then one of the topics that came up is resilience. So we have to build systems and environments that are resilient. And he mentioned there are kind of 3 key imperatives: adaptability, autonomy, and security. Now, here's a question: what do these 3 imperatives have in common? I have an agenda. Yes, of course, I asked the question with an agenda, but what do they have in common? What they have in common is that they're not functional. Security is not part of the function of a system. Autonomy is not part of the function of a system. Adaptability is not necessarily part of the function. The function of a system is to connect a video call, is to see your Twitter feed or whatever your preferred social media is, make a payment, get a payment, do remote education. That's the function of the whole thing. But what he mentioned there is 3 non-functional aspects. And why are these important? Because we're quite good in the engineering side to build complex systems. A system with loads of things, that are interacting, that are inside. They don't have to be complicated. That's something we'd be worried about, but complex systems is something we're actually quite good. We have autonomous cars driving alone. We have planes that land themselves. It was 1960s when people, put a rocket on the moon and a man there. Voyager is out there. So we have very complex systems on any kind of complexity. And the function that we have in these systems, we can build. But to make a system successful, you need to have the non-functional parts being solved. The crossover between technology, socioeconomic environment, and today probably climate, green, and sustainability, because that's important when you look at how the climate is changing and how it impacts our life. And the non-functional parts are really important. And what we want to do is rebuilding a grid that connects cloud with enterprise and IT with communication, mobile, fixed, wireless, satellite, whatever your communication means are, to solve socioeconomic problems. There's social, there's economic, there's a business, and there's a life, and there's a life and business, and a business and life. Yeah? These things go back and forth. And hopefully we can do our good to actually improve the living conditions, and that also means the environmental conditions, everything that goes into climate, our own environment that we live in. So that's the kind of thing we want to do. And of course, I'm an engineer, I'm an architect, I work with Canis and Mayhem, and I'm fascinated about doing, techie stuff. But the best way to explain the grid is coming back to the non-functional things, is to actually an outside-in view, not inside-out. The non-functional aspects, they're really important here. What is the grid then? Well, the grid is a utility, application-friendly, that delivers anything, anywhere, and empowers your world, your digital world, and your real world. The digital one being part of the real world here. That's what the grid effectively is. None of these things is functional. None of these things is technical. All of these things are, how can I use it? Where is it? How does it help me to do my life, to do my business, to do my education? And that's what we're focusing on. So grid is a structure, is a construct. We borrow this from the electronic grid, or the water grid, or the transport grid, or the road grid, or the railroad grid, whatever grid you want to take there. You always have some of these things around you. What important is the utility function. So what we're going to build is going to be there for you whenever you need it and wherever you need it, as long as we have a digital connectivity towards it. Right? We need some communication link in there to be there. But as soon as we have this, we want to have the utility just being there to be used whenever, wherever, however. Similar to electricity and water. My 7-year-old thinks that water and electricity come out of the wall wherever he is, at school, at home, at after class. And this is something that the grid should be as well. It should be just be there. You just don't need to think. You just go and do your stuff, and the grid is there to help you. That's the utility function. We want to go deliver anything that needs a bit of explanation, anything we do digital. So we're not doing physical logistics. We're not, shifting packets. That's someone else's business, not ours. But any asset or artifact that is digital, like data, workloads, whatever you have, your personal files, if you want to shift them around, files from the government, any kind of video, audio, streaming, all these things are digital artifacts. And this is what we mean by anything. And we want to bring it wherever it's needed, or wherever it makes the most economic sense to be, or wherever it makes the most environmental sense to be, and then measuring these things against each other. So for instance, one problem we have in data processing is that we're shifting huge amount of data to the process. That's expensive, sending data on a continuous basis. Most of that data is not useful or not used. So we can also think about bringing the process to the data, or do both, whatever the leveling between the two is, or bring the data to the process if that is the best way forward, or bring the process to the data if that's the best way forward, not dictating any of these things. So that's the anything. And then anywhere is, we want to enable things. So we want to bring things to any location, but we also want to have service access at any location. That's a bidirectional thing. We want to make sure that everything is at the right location to be used at the right time. But we also want to make sure that everyone who's connecting to the grid actually can enjoy the grid and can use this. The whole thing is open, which is important. And openness means we never have an either or question. It's not this or that, this technology, or that technology, or this methodology, or that methodology. What we want to have is that we actually inviting everyone to come in and build the grid. So this is now something we want to see Cole Crawford from Vapor.io talking about the Open Grid Alliance, because that is the forum where we channel our grid activities. And with that, I would hand over to Cole. Enjoy this one, it's really good.
So when we talk about 6G, we must first acknowledge one of its main goals is to support microsecond latencies, an idea that simply doesn't work with the internet that we've designed today. The internet, as we know it, was built for availability, not performance. Today, device and data volume is shifting from the internet's center out to the last mile networks and the eyeballs that live at the very edge of these networks. Yet the internet backbone doesn't extend to the edge today. New applications are making demands on the network that just can't be delivered. And the scarcity of the interconnection required to facilitate the network handoff for this performance-based internet that we need to build will force us into thinking about infrastructure further out at the edge. The internet was built from the core out, and we need to build the edge in. Further, the internet needs to evolve, and the Open Grid Alliance, I believe, is the way that the evolution of the internet will bring about a paradigm shift in workloads and applications that are much more performance-centric across all aspects of our daily lives, from manufacturing to industrial agriculture to supply chain automation, smart retail, et cetera. Together with VMware, Dell, DriveNets, Packet Fabric, a number of other founding members and new members that we'll soon be announcing, we are building the Open Grid Alliance, which is purely focused on re-architecting the internet for tomorrow. At the OGA, we are accelerating a decades-long journey of innovation at all levels of the stack, from fiber optics to workload automation. We're aligning thought leaders, we're aligning technologists and technologies, and we're aligning the investments necessary that simply can't be delivered on the internet we've got today. Open Grid Alliance has an overarching goal to benefit society by engaging commercial and community forces to dramatically accelerate the transformation of internet infrastructure, past its legacy core-to-edge framework into highly democratized, highly distributed platform for next-gen apps and services, again, built edge in. The OGA will be software-defined from the get-go, and it will traverse all aspects of the internet as we know it, from the fiber optic networks in the ground to multiple clouds, multiple carriers, unlicensed spectrum, private enterprises, et cetera. And it will be constraint-based, right? The OGA is meant to start automating some of the decision-making that we today explicitly define in our code. I believe the ultimate implementation of the grid is when you are setting standard deviations for everything from price to latency to jitter to throughput, perhaps even carbon. And this mission will take billions of dollars, and this mission will take decades. But the mission is noble, the mission is just, and I want to thank Kamis for being on this mission with us.
Oh, what a great vision. Thank you so much, Cole. You're always so inspiring. So folks, OGA, the Open Grid Alliance, is something that we are very, very passionate about, as you may have seen with Cole and Sven's talk. I personally am fully invested in the OGA and very dedicated to making the impact to the world, building an open grid. So OGA basically is not a industry consortium in the sense that you see standard consortiums like specification body or open source initiative. OGA basically is a think tank. It's where we do innovation, we do experimentation in sites called grid innovation zones. And then OGA is also a place that will foster global business across the grid. So let me pause here on the grid innovation zone aspect of it, because it's the grid innovation zone that we see as the beachhead to start experimenting and fostering the new technology assets that are needed to be created for the life in the 6G era. So you heard Susan talk about the research to market lifecycle approach to defining the roadmap. You heard Tiaga talk about the ways the governments and the private sectors are fostering the research and creation of new sciences. And then, of course, you heard a very passionate talk from Sven and Cole about how we are setting the underpinning fabric for 6G, preparing the world for the onset of 6G. That basically is our path to 6G. There may be many other paths that other companies and other industries are exploring. We plan to touch base with you hopefully next year and give you an update on how successful we are on this path. Thank you so much for listening to us.